Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're looking at problem 38 in this video, which comes from lesson 10.1. What they're telling us is we have two functions. One is named f of x, one is named g of x. And they've given us the equation for f of x. And they're asking which of the following functions can represent g of x. Well, we know, based on this statement at the beginning, that f of x and g of x have to be equal. They have to be the same function. Now, you might take a look down here and say, well, none of these are the same function. None of them have this 5 in here or a 3 in here. How can any of them be the same? Well, remember that functions can look different if they're in different forms, but they're the same if they make the same graph. So what you could do for this problem is you could go through and you could try to graph f of x, and then graph all of these and see which ones are equal. That's a little bit too much work for me, but I am going to give you a couple options of what you can do here. What they probably want you to do is they probably want you to take this f of x equation, which is in HK form or vertex form, and they want you to convert it to standard form. And we can actually do that one pretty quickly, right? It looks like this. 2 times x minus 5 squared plus 3. In order to convert this to standard form, we're going to have to get rid of the parentheses and the square. But because f of x is over here, we're not going to undo everything. We're not going to subtract 3 from both sides, and we're not going to do a square root. So if you did a square root, you'd have to do one on the other side, and there's all sorts of trickery involved. Instead, we're going to realize that we know what a square means. We know that a square means x minus 5 is multiplying times itself. And you should notice that the square is only attached to the x minus 5. There's no square on the 2. Okay, and then there's still a plus 3. So to multiply this out, you can do this in one of two ways, and I'll show both just to make sure you're comfortable with it. Option 1 is we can just go straight through, do a box, and multiply x minus 5 times x minus 5. I'm going to multiply all of this out. And that will give you x squared minus 5x minus another 5x plus 25. And so we end up with f of x equals the inside of the box, x squared, combine your like terms, negative 10x plus 25. And we still have a few other things though. There's a plus 3, and this 2 was attached by multiplication. And I can't just say 2 times this equation because 2 was multiplying by all of this. So I actually do need to group this into parentheses. From here, we're much closer to standard form because we don't have that square anymore. And I bet you can see the last couple steps. We're going to take the 2 and distribute. That will drop our parentheses. This gives us 2x squared minus 20x plus 50 with still the plus 3 at the end. And this finishes off with 2x squared minus 20x plus 53. Hopefully this matches an answer. 2, negative 20, 53. 2, negative 20, 53. Yeah, it looks like C to me. Now, I mentioned there are a few other ways to do this. The second way that you could do is you could convert each of these back to vertex form. Or in particular, you could find the vertex for each of them and see if it matches the original equation. Because in our original equation, we can see the vertex very clearly. Positive 5, positive 3, always the opposite of h, comma k. So if it's the opposite of h, comma k, 5, comma 3, then you should be able to take each of these, and I'll show you this first one right here, and say, well, if we find the vertex, does it equal that? Remember, to find the vertex in standard form, we can do that negative b over 2 times a thing we've covered in the last couple videos. So there's that invisible 1 here. Looks like we'd get negative 10 over 2 times 1. So that's 10 over 2, which is 5. And so we're matching right at the beginning. Then let's look at the k value. Our k value, of course, means take the 5 and substitute it in over here. So we have 5 squared minus 10 times 5 plus 28. As we go through, 25 minus 50 plus 28. We end up with negative 25 plus 28, and we end up getting 3. And you might say, oh, 5 and 3, that is exactly what we wanted to get, isn't it? Well, sure, But also notice that there's a 2 out front of the x, and here there is a 1. So as soon as you see that the a value doesn't match up, we probably didn't even need to go through all that hk stuff, because we need to match the a, the h, and the k. And although h and k matched, a does not. If you wanted to try b, and I'll just give you one more, right? If you wanted to try b, h equals negative 10 over 2 times 2, right? We got those from up here. That gives me 10 over 4, and 10 over 4 certainly does not make 5 that we got up here. So we know b is out, and so on and so forth. So you could find the vertex for each one and see which one matches the vertex up above. C will work, I promise. Regardless, the way they probably want you to do it is multiply everything out, but you could also find the vertex for each one, see what matches, but don't forget to check that a value as well. Thanks for tuning in. Keep up the success on studying for your final exam in semester 2.